next speaker, Phil, who will be making the next presentation. Let's try to stick to around 15 minutes for each presentation, so we have time to listen to everybody here. Yeah, we have another hour or so left with us. Thank you.
So, thank you. As I mentioned before, I'm Phil Beecher with Y-Sun Alliance. I've got a huge presentation here with loads of slides, and hence I'm going to skip quite a lot of them. I also have a couple of animations here, which I think some people have seen before. They're on our booth, so if you haven't seen them and you want to know more about field area mesh very succinctly, come down. So I think what I'm going to try and focus on now is some of the considerations that you need for large-scale outdoor IoT communications networks, and focus on wireless and the security implications of these, some of the things you need, the vulnerabilities and the mitigation strategies that we've used in developing the Y-Sun fan profile. So, with that, let's go straight in. So, we've talked a lot about IoT. There's a whole load of different sorts of IoT networks, from the body area networks, medical type networks, things like Fitbit, office networks. Utility industry has actually been using IoT networks for a very, very long time, before they were even called IoT networks. So SCADA systems have been out there for ages. That's an IoT network. So actually the utility industry already has loads of experience that other industries are still catching up on. But there are lots of common network protocols that have been defined over the course of the years, going right back to the beginning of the internet. And the internet was originally a project done by DARPA in the US to set up a fault-tolerant and resilient network for the defense agencies to connect 5 computers together. And the whole internet has developed from that. So there's a lot of really good lessons we can learn for mitigation strategies for things like hack attempts, but also real things like denial of service, which are a big problem. So if we look at IoT field area networks, what do we need? They need to be highly secure. They should be easy to install and maintain. Utility and smart cities need the ability to scale easily to thousands of nodes. They need to be reliable and resilient, and that's something particularly important to consider for wireless networks. Energy efficiency is another area here. If you look at some of the really low data rate technologies that are around, I think it's been estimated it would take 3 weeks to do a public key authentication mechanism. Low cost, and it might be interesting to come back to this in the discussion, because if you look at very highly secure systems using certificates, for example, the whole business model for certificate authorities is set up for a few thousand certificates with expensive certificates on websites and maybe enterprise, not tens of millions of certs. Yep. So that's a really interesting area. And people will say, certificate-based security is expensive, but that's the way it's structured at the moment and not the way it will become structured. And interoperability is really important. So other fan challenges, anybody who's in the utility industry will know all of these. The fact that you have problems with weather, terrain, even things like foliage cause you a problem. And as the utilities try and deploy more sophisticated processing options, you need much higher data rates. Latency and channel capacity become important, particularly for wireless. So another thing is that deployments tend to be evolutionary. You don't just put everything all in at the same time. There needs to be a strategy for deployment. There are going to be applications and devices that will be integrated into the lifetime of the network that a lot of people don't even know about. And you ultimately need multi-vendor interoperability to be able to support new applications, new communications products coming in, and you need that backward compatibility and interoperability, so you need to be able to have organizations that manage that. Where am I supposed to point this? Ah, there, okay. So the background of what we're doing in YSUN for wireless communications actually came out of the US utility industry when in 2008, Pacific Gas and Electric, who were responsible for San Francisco Bay Area and Florida Power and Light, started buying proprietary large-scale peer-to-peer field area networks for metering AMI applications. And I think between them, they ultimately installed about 10 million meters. And at that time, there was proprietary technology from a number of different vendors, some of whom are represented here. What both PG&E and FPL wanted was standard, so they weren't locked into any particular vendor. There was a development went on called 802.15.4G. The initial focus was smart utility network communication, but what we've ended up with is something that's actually optimized for large-scale outdoor wireless mesh networks, the field area network. And that finally published in March 2012, revised in 2015. But that work is still going on, which is why I'm a standards evangelist. We came out with basically a standard that's actually supported by the radios in tens of millions of already installed meters. And I think the key thing here, lots of this is just marketing spiel, but the key thing at the bottom here is that the work has gone on as more regions open up frequency bands for this sort of technology. We can continue to do the standards work. And just this month, 865 to 867 megahertz standard, which is 802.15.4U, was published. And there are people that are pretty active in ISGF that have been involved in this. So there's another standard that's almost finished sponsor ballot that covers frequency bands for Europe and other parts of Southeast Asia. Same radios work in all of these areas. Product vendors can basically produce a product that can be used in a whole load of different geographic regions. Okay. This is an animation which you are not going to see, but you can come to our booth and see it. But it might have been quicker just to see it, actually. Hang on. Can you move on for me, please? Can you skip this one? Thanks. This is actually on our website, it's on our booth, and it's a very good summary of why a mesh network is good in a smart city application. Okay, that's good. So you have a standard, but you still need a testing and certification program. YSUN was formed to do that. I'm sure most of you know about YSUN Alliance. If not, come to booth L11. Let me get on to the more important stuff here. So cybersecurity, there's a number of concerns and challenges. Our concerns really about loss of confidentiality, which relates to privacy, loss of integrity, so in otherwise unauthorized modification or destruction of information, the loss of availability. So this is what you get from a denial of service attack, and wireless radio systems are vulnerable to this, and it doesn't matter if you're licensed or unlicensed, because a hacker doesn't actually care. They're going to come into a license band and basically mess with it if they want to. there's some challenges. IT devices are often constrained. They're small, they need to be cheap, they have limited resources, they have a limited user interface, which actually is a good thing in some ways because people can't use passwords. And as we know from the recent hack that happened in Eastern Europe, that the vulnerability was actually exposed by a password hack in the first place. So all of these devices may be easily physically accessible. So even if you can't do a cyber attack, you can basically break into a device and maybe install new firmware. In the US, meters are usually mounted outside buildings. And wireless networks don't suffer from the benefits of wired networks because people can listen in pretty easily and they can be interfered with quite easily. So look at some attack models here. Eavesdropping, this was mentioned earlier, where you actually capture packets over air and then you can do some cryptanalysis or traffic analysis later on. And this is quite a difficult one because if you're sending metadata, revenue-based data, it doesn't matter if a hacker decodes it in real time. They can sit and look at this for weeks afterwards and work out how to deal with it. So that's difficult. Traffic analysis is pretty difficult to deal with as well. A benefit of having something like a mesh network is that because you're routing through different routes regularly, then the traffic is not necessarily of any use. Message injection, really important. This is where you can push some bogus control information into the data stream. So if you're operating a DA network and somebody decides to start messing with the switch reclosers, you can cause big outages. Modification, so this is a man-in-the-middle attack, another problem. Here we come to the node capture. So I think this picture just shows somebody stealing some power in a particularly dangerous way, but they could actually be hacking in and compromising the code that's running in some DA equipment. And then particularly of trouble for wireless are denial of service attacks, and these fall into two groups: service degradation, where you basically intentionally collide, so you know when a radio transmission is going to happen, so somebody squirts another radio transmission, or service disablement, jamming, where you just have a really high-powered transmitter, or you transmit preamble for the radio, and you just lock out a whole radio system that way. So these are all a whole load of things you need to consider designing a wireless system, and if you're a utility, probably ask your vendor how they deal with all of these when you're purchasing. So you have to consider all this stuff, but also you need to consider how secure does it need to be? How secure does your network need to be, and what level, what's the lifetime of the data? Regulations, minimums, determining minimum security, and those things like data protection laws. So in Europe, the protection of data is far more stringent than the US, I believe, and it's different in different European countries. I think these last two bullets in this section are compromised, because can you bear the cost and complexity and energy consumption of the security you need, but can you afford not to implement the appropriate level of security? So I think technology is going to continue to move on this. And a really good document to read is this NIST 7628, and there's the link in the presentation. And in my opinion, this was one of the good outcomes of the SGIP activity. It's a guideline for covering use case and threats algorithms, key management for all of the communication domains in a smart grid. And I think there are thousands of use cases in this. It's a big document, and it's great to go to sleep to, but it's worth reading. I think probably everybody knows about interoperability and the benefits of that. I'm sure everyone knows about Wi-Zone Alliance. If you don't, come and see our booth. So I'm going to skip all of this, if I can. If you don't know us, I haven't done my job very well, actually, over the past few weeks. What we do, YSUN certifies communication layer protocols, though. So the key thing is we don't develop any of the standards. We just take open standards, create a profile, and then provide a certification program for working on that profile. So it's all about the comms. It's not about the application layer or the utility office or any of that. So in some ways, our job is easier. This I will show. So we have basically two areas, two application domains that are interesting to YSUN. On the left is the field area network, which is connectivity from smart meter through to data aggregation point, which can also include the distribution automation network. This is a field area mesh, requires very, very strong security because this can compromise whole chunks of the grid. On the right-hand side is the activity we have for home energy management and HAN working groups. We had a little bit of a discussion earlier about topologies here, and this diagram actually shows what's done in Japan, where does the pointer work on this? Which one? No. Okay. Ah, it does work. Superb. This one here. Top one. Ah, the red one. Okay. Okay, good. So we're on the right-hand side. This topology is really interesting. This is what TEPCO does in Japan. And here they actually have a connection between the smart meter and the HEMS controller, and then the HAN, the home area network, is the connection here. So the security for the utility sits in this domain here, and then the policy adopted by the user, the HAN, sits here, and the point is here. And this is slightly different from other topologies. And what it means is the responsibility for the HAN falls very much on the homeowner, the person who's actually running this, and it helps provide a much more robust interface here for the utility to protect its data. So something worth considering. Yep, sorry. Oh, God. Okay, so we have an application. This is our protocol stack. It's a bit of an eye chart. It's all based on open standards. We have a chunk of security down here, which is all open standards based. YSUN fan security uses extensible authentication protocol based on 802.1x. So this is standard, and RFC, an IETF standard 2284. We use EAP-TLS for providing mutual authentication of the server to the client in addition to the client to the server. So this is the same protocol that's used to establish HTTPS, but with a client-side certificate as well. So it's basically enterprise-level security. So open standards-based, strong security. We had to do some extra work within the 802 community to provide a transport mechanism for carrying EAP-TLS over a 15.4 network, but that was done in standards. Whoops. Okay, and I'd like to finally come to collaboration. So when you're talking about IoT, there's no single organization that can support all of the applications. There's no single standard or set of standards that can address all of these. The ability to do new applications research and enable technologies is essential. Standards organizations, industry alliances, and academic institutions can all specialize in their own expertise, and you have good collaboration between stakeholders. So for example, YSUN Alliance has Republic of Singapore University who's doing some work on security for IoT type applications. So we'll work with them and help them take this into standards environment. So a number of collaborations that we have ongoing. Membership, this is promotional information, so I probably don't need to talk about this. However, if you want to get hold of the YSUN standard, you can join as an adopter member free of charge and download the spec and then take it from there. And there you go, I'll finish there.
Thank you very much, Phil, for the